Okay, welcome to another lesson for Greenhouse Technical. Today we're talking about spray equipment and some of the caveats around spraying. This is a topic not everyone likes, but it's a reality in agriculture. Obviously, no one really likes to spray a lot, and in the recent advances with IPM, spraying has become less common. It still happens, but it's not like what it used to be. So that is fantastic for us, for our own health and all that other stuff. But so I want to introduce you to some of this, and then when you come to campus, I'll show you a sprayer unit, and we'll do some hand spraying. Um, why spray? Well, there's the two main reasons in greenhouses. That's pest control or plant growth regulation. So, you can either eat the bugs or spray them. Um, so some strategies that I want you to be aware of. So what I would say is generally you spray at the end of the day. If you remember from our climate class, uh, as the day cools off towards the end of the day, your humidity from all the plants transpiring ends up kind of trapped in the greenhouse, right? Because the sun's going down, the temperature cools, and if you have a fixed amount of moisture and the temperature drops, your relative humidity goes up, even though the net moisture hasn't changed. So that at increasing humidity level towards the end of the day is beneficial because when you're spraying your chemical, um, you don't want the droplets to dry up too quickly. You want to give them time to spread across the leaf and to stick to it or to absorb into the leaf. If you have a very dry climate, when you spray, the droplets dry quickly and the chemicals left on the exterior of the leaf, which may be okay, but it may be left in spots and not evenly spread across. Or if it's a systemic chemical that goes into the tissue, it may not have had time to absorb and it's left as crystals on the exterior of the leaf in spots. So we need to give it time to absorb, and that can be anywhere from, half an hour, 50 minutes to even 50 minutes to a couple of hours. So um, yes, you might say, well, what about powdery mildew? Well, one night of spraying isn't going to bring about a major outbreak of powdery mildew. Plus, not to mention you're spraying chemicals, which are often not conducive to powdery mildew growing. So I wouldn't stress about that. The other reason why, at the end of the day, is that staff are gone. So that means you're not exposing people to chemicals. Um, It also means that you close your vents at the end of the day, right? If you're closing your vents, you don't have to worry about the greenhouse overheating because the first point, you want to have high humidity, but because you're closing your vents, you're not worried about the crop overheating. The other thing to remember is to turn off exhaust fans if you have forced vents in your greenhouse because the that will just suck the chemical out and blow it out into the atmosphere outside. We don't want that. We want it settling on the crop. So the other thing to keep in mind is reentry periods. Now, when you take your spray license course, which I hope to be setting up soon, you'll learn about some of this stuff. But the reentry period means that staff cannot reenter the greenhouse for 4 hours to as much as a week, depending on what you spray. The vast majority of chemicals have a 24-hour reentry period. So when I had my greenhouse, if I had to spray, I'd spray on a Friday or a Saturday. Um, and that would mean that there's no staff till Monday. So the greenhouse had plenty of time to ventilate, and there was no smell or volatiles that they would inhale. Um, Again, like I said, spraying's a lot less common now with bios, so that's good. Another important thing is you want to make sure you have your HAF fans on. Sorry, I'm trying a touch screen so I can draw a little better, but it's giving me some grief. Um, when you're spraying, the HAF fans, depending on whether you have them on or off, is useful for dispersing the smoke or fog around the greenhouse. It doesn't mean you usually leave them on all the time. You might use the HAF to spread it all, and then when you're all done, shut everything off and let it just settle. Um, so we'll go through all the different techniques, but I want you to think. You have to think kind of like uh, as if you were the fog. What would you do? How would you behave in the plants? Are you going to swirl around the leaves? Are you going to get down into the nooks and crannies of the plants or not? What help do you need to get there? That's basically what effective spraying is all about. Um, Choose your equipment based on what you're applying. So there are a couple of interesting things here. There is systemic chemicals and there are contact chemicals. Um, Systemic chemicals are chemicals that when you spray them onto the plant, they're absorbed into the plant, and they can do one of two things. They can absorb sufficiently to move into the phloem and then move throughout the entire plant, so the entire plant is protected. Or they're what's called translaminar, which means that they absorb into the leaf and they stay in the region of the leaf, but they don't make it to the phloem to be transported to other tissues. So systemic, true systemic chemicals, it's less important that you are absolutely uniform in your coverage. Whereas translaminar, you probably need to be fairly uniform. And then there's the last one, which is contact. These are the chemicals where you have to evenly coat the entire surface of the plant on the exterior because it doesn't penetrate the plant. Um, to give you an idea of a systemic chemical that is very effective, Roundup is basically a chemical that kills plants not through toxicity, but it's a broken amino acid. And when you spray that on the plant, it disrupts the formation of proteins in the plant. And that chemical is able to move through a leaf into the phloem and move throughout the entire plant. So, for example, agricultural crop growers like corn, soybean, and stuff like that, they can actually have a cloth that's wicked with Roundup and they just hang it above their crop so it's not touching their soybeans, for example. But any weeds that are sticking higher than the soybeans and happen to touch the cloth will pick up a small amount of the Roundup, and then it will absorb into the plant and move through the tissues and kill the entire weed, because the little molecule disrupts the entire protein formations inside the plant. And plants need to continually replace their proteins. That's how animals and plants work. We're not losing them. It's sort of like Lego kits where it assembles the kit, uses it for a while, then the kit sort of falls apart. So they have to remake the kit, so to speak, in order to keep that protein active. That's how the body regulates things. Otherwise, once you make an enzyme, you can't stop it because it just keeps going and going and going like a sorcerer's apprentice. So um, Roundup gets into that mechanism and disrupts the formation of proteins. And so the plant survives until all its proteins have sort of disassembled and then there's nothing functioning anymore and the plant dies. I thought I'd explain that because a lot of people think that Roundup is toxic in the sense that it kills plants through toxicity. That's really not how it works. It's a pretty exquisite system. I'm not saying it's a great chemical. It has all sorts of other side effects, but I will mention that people who are so keen to get rid of Roundup don't realize that farmers are now switching to chemicals that are in fact toxic, like paraquat. And that's a really big problem. So we need to better educate farmers and people so that we can make healthy decisions. Anyways, enough of that. But so depending on whether the chemical is systemic or contact, we need to determine what we're going to spray. So if it's systemic, we don't need to make sure we have uniform coverage. We can just, spranch it all over the place and it will move into the tissues. But if it's a contact, we need to have adequate equipment that will create enough fog and turbulence to cover and coat the entire plant. Um, Another thing that factors in how we choose what we're spraying is the chemical type. So there's wettable powder, emulsifiable solutions, and water soluble. They're the main three. There are a couple other designations, but this covers the major ones without me getting lost in the weeds here. So wettable powders do not actually dissolve. So you put them into a tank and they'll mix up into sort of a cloudy haze, but if you walked away and came back in an hour, it would all be at the bottom of the tank and you'd have kind of a clearish water at the top. So that's something that needs to be agitated continually in order to make sure you're getting an even dose when you're spraying your crop. The other thing is that wettable powders because they're tiny crystals, they don't pass through very fine nozzles very well. So you have to be aware of that. Emulsifiable solution, these are a lot of the old toxic chemicals are like this. In chemistry, you have sort of two main categories that chemicals are soluble in. Either a chemical is soluble in oil or the chemical is soluble in water. Now, chemicals that are soluble in oil require a solvent in order to mix with water. So if you can think about it like paint, you've got water-based latex or you have oil-based paint. And you can't mix them necessarily, and you can't over-apply them because they have different chemical properties. So when you're dealing with an emulsifiable solution, it's kind of like saying I've got an oil-based paint. And when you mix that with water, the solvent that's added to the chemical helps that chemical to blend with the water, but it never truly solubilizes. If you left it long enough, it would actually separate into a layer on the surface. So it's not like a wettable powder in the sense that there's gritty crystals that settle to the bottom. It's more like if you've ever had whole cow's milk and you don't homogenize it, eventually the oil part settles to the surface and the water-based parts of the milk settle to the bottom. But if you blend it quickly enough, and the milk you buy is blended, the milk will stay sort of homogeneous for quite a long time. And I mean, if you buy homogenized milk or homo milk, that's whole milk. And what they've done is they've put it through basically a high-speed blender, which whips up all those oil droplets into very small oil particles. And it takes a very long time for them to reassemble and separate to the top of the milk. So EMS, or emulsifiable solutions, are oil-based chemicals that you need to make sure you also have decent agitation. I'll tell you this, from a health and safety standpoint, typically emulsifiable chemicals are more toxic because oil-based chemicals are difficult for your liver to process, so they have a more toxic impact on your body. So having said that, a lot of new chemicals on the market, and this is good news, are water soluble. And water soluble chemicals means when you add them, they fully dissolve and they stay in suspension indefinitely. These are the easiest to work with. And from a health and safety perspective, because your liver can process them easily, they are almost always very, very low toxicity. Unfortunately, the corollary is true that because they're water soluble and they're easily processed by an animal, whoops, let me put my eraser on. That means that insects can also break them apart and sort of, in a sense, develop their own resistance more easily. So a lot of modern chemicals have a limited lifespan, whereas some of the old EMS chemicals, like Vidate or Dursban, diazinon, those things, which were very effective and very toxic, they're still effective to this day. So a lot of farmers will say, oh man, I miss the good old days when I could use the good stuff that really worked. Well, that may be the case, but they were spraying stuff that was persistent in the environment, that was killing themselves. Many farmers die from cancer at a younger age because of these chemicals. They're just bad. And when I was talking about Roundup, the paraquat that is replacing Roundup is an emulsifiable solution, and it is incredibly carcinogenic. So for people who think that they've had a victory by getting farmers to use less Roundup, I don't think they realize that what they've done is they've made their own lives probably a 1,000 times worse. So it's a huge problem. The other thing to look at is, will it work in a fogger? So wettable powders, because they're gritty, tend not to work very well in a fogger. A fogger is essentially trying to let me get my pen working. A fogger is essentially taking a solution and it's going to create a very, very small droplets in the air that stay in suspension. You can move them around the greenhouse and eventually settle on all the tissues. Wettable powders are not compatible with that, so you need to make sure you're using an EMS or a water soluble for a fogger. Another thing is it heat labile? That means that if it goes through a thermal fogger, is the chemical actually coming out the other end the same chemical? Heat labile means that when you heat it, it breaks down. So some chemicals, you have to read all the chemical labels, but you look carefully. If you're using a fogger, especially a thermal fogger, make sure that the label says that it's compatible. Otherwise, you're just wasting your money. I've got a picture up here of leaf miner, and This is a good example of a chemical, a situation where you need a systemic chemical or a translaminar, because that leaf miner larva, it's moving between the exterior epidermis, between the top and lower epidermis of the leaf. It eats all the mesophyll in the middle. So spraying a contact pesticide is not going to work. You need a systemic one that's going to go into the leaf, and when they eat, the larva eats through the leaf, it's going to eat that systemic chemical. Um, you've seen that we have a boom at the college, and that is another interesting way of applying chemicals. You can put a dosatron on there, and there's your chemical, and away you go. As it irrigates the crop, it sucks up the chemical into the irrigation water. Um, this is often how systemic chemicals are applied, mainly because with fertigation, you're irrigating larger volumes. So you have a dilute solution that goes into the soil, and then the roots of the plants take it up, and then it goes through the entire plant. Um, but doing a drench requires a lot of chemical. So if it's a very expensive chemical, typically farmers don't do it. But it depends, you know. I mean, this is propagation here. There's a lot of high value plants there, so it's probably worth it. But if you just had, 10,000 4-inch pots, there's not a lot of money there. You start spending thousands on each drench, that's not going to make any money. Um, pH can be an issue, so it's important to note that, because plants are absorbing to the roots. That means the chemicals are going to be in the soil for a while, so you have to make sure the chemical is compatible with that pH. Um, the other thing is you got to make sure you get your dose right, because when you dose that much chemical into the plants, you can't remove it. You can't wash it off. It's in the soil. And the plants are going to they could take a toxic dose. So make sure you get your calculations correct based on the label's rates, or you could do a lot of damage, and you wouldn't be the first person to have done that. Then there's the workhorse, the hydraulic sprayer. Hydraulic sprayers, this is what I was going to demo at the college. There's a hose reel, and you just pull this out, walk down the row, spray, and then wind the hose back. If you're very lucky, you have an electric retract reel, which will help bring the hose back into the sprayer, but not many farms have that. They're fairly expensive, but they are nice. Um, Hydraulic sprayers can spray every formulation of chemical, whether wettable powder, water soluble, EMS, anything's compatible with them. They typically have an agitator inside here to keep the water moving in the tank so that wettable powders don't settle. They are labor intensive. I sprayed my farm with foggers and hydraulic sprayer. And my hydraulic sprayer, we had a 1-acre farm. It would take me about, I was going to say, 3.5 hours to spray the entire greenhouse. So you wait till the end of the day. So people say staff leave at 5 o'clock. You can see you're going to be working late at night. It's tricky, especially in the winter when days are short. You got to put your grow lights on, and you're wearing your suit. You're dragging hoses around. It's not fun. No one likes it, but it has to be done. So sometimes you got to see how much time it takes, and maybe you have to have two people spraying at once, or you have to look into some of the other methods of spraying, which we'll talk about next. These are the different guns that are used with hydraulic sprayers. This is a very common old school one, the green gun, or whatever it is, a P9. Basically a trigger, and this barrel can rotate to make a coarse or fine fog. This gun here I really, really like. It's called a Galaxy gun. I recommend it to a lot of farms. It has a lever here, which you can dial to adjust the spray pattern to make it coarser or fine. But what really makes the Galaxy gun shine is that this nozzle, this red nozzle, slides in and out along the stainless steel shaft. And you can't see it in the picture here, but there's air vents in it. And so as the spray gun shoots spray out the nozzle, it sucks air in, and that air mixes with the spray, and it creates a turbulence, and it creates fog. So you get much more uniform coverage, and the beauty of it, you use way less chemical. in my early days of spraying, I had one of these green guns. And to put it in perspective, I went through about 400 liters to spray my farm. And when I switched to the Galaxy gun, I could get the entire farm done with 200 liters. And I had just as even coverage. So that was a huge cost saving in chemicals and saving my time because I didn't have to mix up a second tank. So I'm a big fan of the Galaxy gun. Um, then there's lastly, oh, it's not erasing. Lastly, there is, let me get my pen working. There's this thing called the Cornell gun. And basically it's like a pressure washer wand, and at the end you'll see there's 1, 2, 3, 4, 5 nozzles, and they kind of, the outside ones pivot, and so you can kind of create your own fog area. Um, I have not used one before. I imagine they're okay, but they don't give you a lot of control over the shape of the fog, just the direction that it all sprays. But it's not a bad gun, but the Galaxy gun is very good. Um, then we get into other equipment. These are called LVMs, low volume mist, or ULVMs, ultra low volume mists. Uh, these are what we call a cold fogger, in the sense that the chemical solution is not heated. It is just put through a very, very fine nozzle, and then there's like a turbo fan that blows a lot of air over those fine particles so that they stay suspended in the air. You can see in this picture here that it's creating a fog in the greenhouse. This is a small unit that's actually used for sterilizing offices for COVID-19. They put basically pool water in there and they just fog the office space, and it settles on all the surfaces in theory and kills COVID. I don't know if it works, but these two here are called the autofog, and they're very common in the ornamental industry. That you can have them mounted permanently up in the truss, or you can have a cart that you roll out into the greenhouse Friday evenings when you spray. But basically, you use your horizontal air circulation fans to help move the fog around while it's spraying, and then when the fogger turns off, it's on a timer. You can sort of look at it, set it for, say, 2 hours. When it turns off, you just tell your Priva or Argus to turn the circ fans off at that point, and everything settles. But you keep your circ fans running while the fogger's going. What's nice is that you can automate this so that it will spray while you're not there. And that's great from a health and safety perspective. You don't have to be in the greenhouse at the time that you're spraying. In theory, you get deep penetration because of the fine fog. It settles into the crop and you get it on the leaves and down deep into the plant. There's usually no runoff, but one of the downsides is that here you can see you don't get as even a fog, and my experience has been that you don't get as dense a fog, and the far corners, the corners of the greenhouse don't get as much chemical as the areas in front of the fogger. So you end up with uneven dosing, and that can be dangerous because you can end up with if you have what's called sublethal doses, those regions are places where bugs can develop resistance. And in the years that I was operating, they started to get a reputation for creating resistance. We used to call them resistant makers, these machines. Some farms still use them effectively. I think the trick is to have quite a few of them in the area so you generate a lot of fog. Some farmers, because they're expensive, they would just buy 1 or 2 and try to do the entire place with them, and that just was not sufficient. The thermal fogger was developed in the 60s, believe it or not, and it has become really popular again because of the LVM's inability to create as intense a fog and as even a distribution. Pulse foggers have become popular again. There's videos on this week's folder that you can look at that will help you understand how they work. But essentially, they use gasoline to create heat and generate air pressure, and that heat creates a fog from the solution or smoke, and that fog is then blown out the nozzle into your greenhouse. And you can see here, this dense fog is just starting and it will progress down the entire greenhouse. You can't see your hand in front of your face. The smoke is so intense. Um, they have the best penetration of any application. Uh, the most uniform, which prevents resistance because you don't get those low dose areas. They are a little scary because they're loud and they use gasoline to make basically a flame. And that's something that you have to be aware of. They have to be maintained properly, otherwise a big flame shoots out the end. There have been fires in the past, so you have to respect the machine and maintain it properly. They're also very hot. The machine themselves gets very hot. Um, I used a pulse fog in my greenhouse the last few years, and I would put it on a greenhouse cart, and I would start it in the barn, and then I would roll it out in the greenhouse and open the chemical valve, and then it would just start dumping smoke everywhere in the greenhouse. And I had set it up so that it would run for 20 minutes and would run out of gas and then shut off. And the smoke was so thick in the greenhouse that you couldn't see a meter in front of you. So very effective at distributing chemicals. Um, it is a chemical. It is mostly effective for emulsifiable chemicals, so oil soluble. It will do water soluble, and it's reasonably effective. But a lot of water soluble chemicals are heat labile, so be careful that your label says it's suitable. Um, there was a chemical called DDVP, which is actually, surprisingly enough, this sounds all horrid, but the DDVP is actually very soft on biologicals. And so that's probably why the pulse fog has become popular again, because you can do a DDVP fog and not kill all your bios. And you can knock back whitefly, for example, or thrip. If your bios are not keeping up, then you can do a quick fog of DDVP, and and you're good to go. It's not going to completely solve the problem, but it's certainly going to give your bios a bit of a boost. Um, that might seem hard to believe, I know, but yeah, DDVP is still used and soft on bio. Not all bios, but a lot of them. So uh, this part's important. It's not always obvious. These little units that you set on a cart or wherever, you would put as much chemical in that little tank as you would in 100 liters for a hydraulic sprayer. Sometimes people don't know how much to add. That's about what you would add. So if you're putting 2 liters in 100 liters, you would put 2 liters in this, and the rest would just be carrier solution. Um, all right. Here's some more pictures, and there's a link down there if you want to watch the YouTube on how the pulse fogs work. But they are very, very effective at what they do. In the greenhouse realm, they use robot sprayers for the most part, uh, which sounds really elaborate, but really all it is a sprayer on a motor that drives it down the row. And when it gets to the end, it bumps the trigger and reverses and comes back. And these often have a centralized tank, which is also very convenient. You're not dragging around tanks of chemicals. There's a line in the walkway, and it has a hose. You just connect into it, and it connects into this robot. And the spray comes from the barn all the way out to that pipe and then down the hose into the sprayer. Um, these are relatively safe, and these two particular ones, the grower has to stand in the walkway, and when they come back after having gone down the whole row, they have to move it over to the next row and shove it in, and then it goes by itself. So you don't have to walk into the crop. Um, a lot of the robots now are fully automated, and they actually will do a row, come out, and then move sideways into the next row. And so you just start it, and it does the entire farm. And they have an error system where if something goes wrong, it will just alert you on your cell phone, and then you come out with your mask and stuff and fix it. Um, Does spraying happen often? No, but it does happen. Uh, there's certain times when you just have to spray. Summertime is particularly tough. In the winter, if you've done a good job cleaning your greenhouse before a crop goes in, there's really no reason for you to have to spray your crop if your bio program is in place and you're monitoring and on top of things. Um, they also use these robots to sterilize the greenhouse before they put a new crop in. So they'll put like a foaming sterilant in there, and it sprays everything with this foam. And then you go back and you rinse it all down, and the greenhouse is sterile and ready to go for your next crop. Now, come summertime, you're well into it. Remember, you pull your crops out in the fall or early fall, so you're looking at crops that are maybe starting to lose their productivity, but you know what? You just spray. The bugs are probably barely keeping ahead of your crop, so it's still worthwhile getting some crop out of it, so you spray at that point at the expense of your bios. This video kind of shows how it works. So he's aligning the robot, and then it goes on the heating pipes, starts to spray, and then hooks up the hose. There's a reel inside the robot, so it unwinds the hose. This is the guy's not wearing any PPE whatsoever, so I think he's just spraying water, but really that's kind of daft because the pipes that he's using would have residual in it. You shouldn't be doing that. You should always have a mask on and wear a Tyvek suit. Some people are still very maverick about it all. Anyways, it goes all the way down the row. When it gets to the end, it'll flip the nozzles to the other side and then spray the crop on the other side and come back. And that's effectively what it is. Most likely spraying for whitefly, I would guess, in tomatoes in the summer. But you know what? It's way better than you hauling hoses down the rows and standing in the spray all the time. This is much, much more effective. Booms again, like I mentioned, they are very effective in propagation areas. I think that slides out of place. Not sure how that happened. Another thing I want to mention is pH. I did allude to it on one of the earlier slides, but um, most pesticides and fungicides are susceptible to high pH. Now, that depends on the chemical. Some are more susceptible, some are less. But the rule of thumb is that once you've mixed a chemical, you should use it. It's never a good idea to store it in the tank. Like, say you overmix a chemical on one Friday, and you say, well, I'll just leave it in the tank till next Friday. Um, that's really not a good idea. Odds are that the chemical will be less than half effective, and in some cases, after 2 hours, no effectiveness. So do your best to get the math right, mix the right amount so you're not wasting it. Um, Fungicides and herbicides are less susceptible, where insecticides are more susceptible, as it says here. There are definitely agricultural buffers. Some spray chemicals have buffer in them to mitigate this. Some sprays recommend having a buffer added. Always read your label, and it'll tell you exactly what you need to do. But yeah, avoid leaving your spray in the tank overnight. Just use it up. This document down here, this link, will take you to a more in-depth thing if you want to read about it, but I don't want to get into it too much because it's not that big of a deal. Okay, I want to go through this list because when you're spraying, these terms are really helpful for you to understand what goes on with chemicals. These things are called adjuvants. So an adjuvant is something you add that improves the performance of the herbicide or pesticide or insecticide, whatever you want to call it. So you got wetter spreaders, stickers, penetrants, compatibility agents, emulsifiers, suspending agents, foliar nutrients, stabilizing agents. Let's go through these quickly. Wetter spreaders, basically their job is to prevent water droplets from forming on the leaves. If you're applying a topical pesticide and it forms beads on the leaf, as they dry, they leave concentrated doses of insecticide where the droplets were and nothing where there were no droplets. So sometimes you end up with yellow burn spots because you had too high a concentration where the droplets were, and sometimes you don't see it at all, but the insects as they're feeding don't necessarily feed on areas where there's insecticide. Or if you're spraying a contact insecticide that has to come into contact with the insect, well, it's going to bead off the leaves, probably bead off the insect and not make contact, and therefore be an absolute waste of time. So by adding wetter spreaders, they basically reduce the surface tension of the water. And here we have a standard water droplet that, because the surface tension forms a big bead of water on the waxy leaf. If you add a wetter spreader, the water is less attracted to itself and it spreads evenly over the car. A really good example of these things is they're sort of treatments you put on cars to make them look nice and shiny after you wash them. And what they do is these spreaders, they don't actually make the car shiny. What they do is reduce the surface tension so the water dries evenly across the surface of the car so it looks nice and shiny, because the droplets, the little particles left behind, are so spread out you can't see them with your human eye. The same thing in your dishwasher. If you add Jet Dry, that blue solution, to your dishwasher, all that is a wetter spreader. So if you have, for example, city water and it's kind of hard, it's got calcium in it, if you wash your dishes and just put them in a rack, when they dry in your glasses, you'll see there's white specks on the glass, or maybe rings where the droplets dried, and your glass doesn't look so clean. So when you put Jet Dry in the dishwasher, it reduces the surface tension of the water so that when the water dries, those calcium crystals are deposited evenly over the entire glass surface, and you can't see them anymore, so the glass looks perfectly clean. That's the exact same thing when we're adding pesticides. We add a wetter spreader so that when we spray, it lands evenly on the leaf. It doesn't bead up, and you get a nice uniform distribution on your leaf. Not to mention, a lot of insects have hairs on them that are hydrophobic and will cause water to bead off them, so that the insecticide's not effective. If you add a wetter spreader, the insect's hairs no longer function as a repellent, and the water penetrates through the hairs and gets to the insects to make good contact so that they die. That's an important adjuvant right there, often called surfactants, because soap is kind of a surface tension reducer. That's how it works. Another one is a sticker, and oftentimes it's as simple as just white glue. They sell you these things in expensive jugs, but it's often very similar to just a latex glue. I've seen this with a lot of fungicides. Daconil is a really good example. If you look on the box here, it says weather stick on the label. And it's essentially a kind of a white glue that's mixed in with the fungicide, because the fungicide is a wettable powder that's not soluble, and it is notorious for being uneven and washing off the leaf. It's very good at controlling powdery mildew, though. So if you are growing a crop where you're not concerned about how the leaves look, you can spray Daconil, and it will stick to the leaves and prevent fungal infections for weeks on end. So for example, if you're a grape farmer and you want to prevent powdery mildew or leaf spot on your leaves, you spray Daconil on a day where the forecast doesn't show any rain. It will evenly, well, hopefully this isn't the most even here, but it'll dry and stick to the exterior of the leaf and not wash off after it's dried. So if it rains or anything like that, it won't come off. Not that easily. It takes like many, many rain cycles to start reducing it. You might ask, does it reduce the photosynthetic efficiency because you're blocking light? maybe a little bit. I don't think anyone's actually really studied that, but to my knowledge, it's not a major concern. But someone might ask that question in class, and I think it's a good question. Um, Penetrants. So these are basically solvents, right? If you've ever worked on a car and you get your hands covered in oil, you know, you can use soap. It kind of works, but usually you get a hand cleaner solvent to get that off. And it's those sorts of solvents that penetrate oily things that are very helpful. Now, with a leaf, most leaves have wax in their cuticle. And you probably inherently know that water repels from wax. So in order to get your chemical to pass through the leaf cuticle into the tissues, you need to add some sort of a solvent. Um, and so that solvent or soap will help the chemical pass through the various waxy plates to get into the cells in order to have a residual effect. Or just absorb into the waxy cuticle so that if an insect eats it, they eat the lethal dose. So penetrants, very helpful. Compatibility agents, these are things that you would adjust based on your water. So if you are using well water that has a very strange pH, you would add these agents, which are essentially pH buffers, to your tank to make sure that the chemical stays at its full effectiveness. Usually it's a phosphate buffer or some sort of phosphoric acid. Um, Emulsifiers, similar to penetrants, you know, they are basically, they're often already added to the chemical. You don't have to add them yourself, but there are odd cases where you would, but I'm not going to waste too much time on that. It's usually in the chemical when you buy it. Um, Suspending agents. This is an interesting one. So remember the wettable powders that are not soluble, then they settle to the bottom of the tank. You can add thickening agents like cellulose or gum that will keep the powder from settling in the tank as quickly. Um, the best example I can give is like salad dressing. You know, if you got an oil and vinegar, if you've ever made your own salad dressing, you'll know that everything, you try to add everything to the liquid and you shake it and it's in, you know, it's kind of in suspension for a few seconds and then it separates. So commercially they add thickening agents like guar gum or xanthan gum that are a water-soluble matrix of sugary fibers. My pen is not working. And the particles, let's say all these spices in here, they're all trying to float to the surface. But because there's this elaborate matrix of guar gum in there, it impedes their progress. And so they stay in suspension longer. And so suspension agents can be added to chemical tanks for the same purposes, to keep your wettable powder from settling too fast. So if you, maybe you don't have very good agitation in your tank, or it's just such a big tank and it's going to take you 4 hours to spray, the suspension agent will improve your success. Again, quite a few wettable powder companies now, if they come as a, it'll come in a, either it comes in a bag as a powder and then you know it doesn't have a suspension agent, or it comes in a bottle and it's liquid, but it's still listed as WP. That means they have a suspension agent in the bottle, so when you add it to your tank, it will also help it stay in suspension longer. Um, then there's foliar nutrients. This is only related to thermal foggers, that pulse fog. They use a smoke solution, a fog. Like, you've ever been to a concert and you have the fog that comes off the stage, that smoke? The same chemical is added to these jugs to enhance the smoke effect with the thermal fogger. And what's really cool about this is they actually add nitrogen and potassium to it. So it's actually a nutrient. So when you're spraying your pesticide, you're also adding a nutrient charge to your crop. And they will absorb it foliarly. So that's kind of a, some growers even just spray this alone if they're trying to fix a nutrient problem quickly, because the plants absorb it right at the leaf, and you can fix a problem quickly. A lot of tropical growers, for example, use these thermal fog nutrients if they're trying to quickly reverse a nitrogen deficiency, if they made a mistake or had a bout of weather that affected their crop. Stabilizing agents, these are less common in the greenhouse industry because we don't spray outdoors where there's a lot of UV light. We're in a greenhouse, but there are agents you can add because UV light actually breaks down a lot of pesticides. Um, so these UV, basically sunblock chemicals, are added to the chemicals to prevent the UV from breaking them into ineffective compounds. Um, that would be in the daconil weather block, for example, to prevent that fungicide from breaking down on the grape leaves over time. Um, and by the way, I have used daconil. I've used it on mandevilla. If you get the dose right and use a wetter spreader, it actually doesn't leave a white residue, and it is very effective at preventing powdery mildew, pretty much for the duration of the crop. But it's not for edible things; it's only for ornamentals. Lastly, and this is kind of a controversial one, these are called feeding stimulants. Um, really unsure as to whether they work or not. And what they are essentially is a sugar solution. This is called Consume, this picture here. But I think basically it's sugar water. And there was a school of thought, there's some doubt on it now, but there was a school of thought with old school growers that when you're trying to control thrip, very difficult to control thrip because they drill down deep into the flower buds where it's hard to get your spray, right? We've talked about hydrophobicity and how water, beads away and all this other stuff. Thrip are usually deep down in the flower buds where it's hard for you to get at them with, whether it's a fog, a smoke. Really, the only thing you can get at them with is a systemic pesticide these days. That's if you're trying to kill the adults in the flowers. Obviously, in the soil, it's a different thing. But if you're going after adults and trying to prevent egg laying or prevent them from doing damage to your flowers, you want to draw the thrips out. If you with your classes with Graham, you probably were told you can take a flower and you breathe on it, with your warm breath, and then bang it over a piece of paper, and the thrip will fall out onto the paper if they're there, and then you can kind of count them to see how many are in your flowers. Um, Anyways, by adding feeding stimulants to the insecticide, the idea was that the thrip would come out of the flower to feed on the droplets because they like the sugar. Um, I haven't done this myself, but I know that a lot of old Dutch growers did that and they swore by it. But, um, I think thrip, for the most part, really, you need a good bioprogram to keep it in check because thrip are resistant to most chemicals. And if you spray a lot of chemicals to control thrip, your bioprogram will just fall apart. So if you have a thrip problem, honestly, your best bet is to go with either a really nasty chemical that just nukes everything, or spend the money and do your bios properly and don't get lazy or you fall behind. As far as hand spraying, which is what I want to show you in class this week if you come in, is just some of the standard techniques used so that you're effective in hand spraying a crop. Now, this is a picture of a helicopter, but it actually demonstrates really well what I want to try to achieve when I'm hand spraying a crop. And that is sort of this swirly motion of the spray droplets. Because remember, most insects attack the underside of the leaf. And if you're just spraying with a coarse stream at the top of a leaf, right, it's not going to swirl around and get to the underside. And you're only going to be treating the top of the leaf. Now, if you have a translaminar insecticide that will move from the top of the leaf to the underside, then fine. But most of the time, that's not the case. And so having the right sort of mist and the motion and the angle at which you spray the crop ensures that you're spraying both the top and the underside of the leaves in the crop. And that requires, nice, steady, sweeping motion at the right angle. You need to assess your spray, check, go back, check, make sure you actually are covering both sides of the leaves. You want to almost be like a machine when you're spraying so that it's even, a nice rhythmic spraying motion. Um, And then, of course, make sure you're not wasting your chemical. If you're spraying so much that the chemical's hitting the plants and just dripping off the leaves nonstop, then you're over applying and wasting that chemical. You're going to burn it through more than you need to spray your crop. Sometimes, though, some insecticides will say spray to the point of runoff. So be sure you read the label. Then, of course, there's how close are you from the crop. If you're too close, the plants right in front of the nozzle get a heavy dose, and the ones on the far side, so if you're spraying like this, you get a heavy dose on this side of the bench and a very small dose on the other side of the bench. So spraying from a higher vantage point and then maybe switching sides gives you a more uniform, even coverage. So those are a few things I'm going to talk about when you come into the class this coming week with the sprayer. Anyways, I hope you found this interesting. I know you're going to, hopefully you sign up for the pesticide course when that happens. Please don't email me yet. I will send out an announcement, but it will happen. COVID has kind of thrown a monkey wrench in my plans since September, but I have assurances that we can do an online Saturday course to get you your license if you need it, and I highly recommend that you get it. Anyways, that's pretty much it. That course will cover some of this stuff, but I think I've covered a lot of the stuff that it will not cover, sort of farmers tips and things like that. But you will go over this sort of stuff and the regulations when you take that class. All right. There are quizzes. There's a spray quiz. I think it's ends up next week. It'll come out next Friday. So all the quizzes will stay open for the duration of the term. I'm trying to put the due dates in so it shows up on your calendar, but don't panic about that kind of stuff. I am only doing 2 attempts this term because, it's great to practice with the quiz, but I get people going from a 90 to a 97 to a 99. I don't want to remark all those things all the time just so you can get 1% or something. If you're desperate to do a quiz again, email me and I will open it for you again, but I need a good reason. Okay, I'll see you later. Bye.